There we go. Good morning, everybody. Sorry I don't have your test smarts. I really did give it an honest try. I did. I'm like halfway through part B in the grading, so shouldn't take too much longer. But I had hoped to get it to you today because, as most of you are probably aware, Friday is Good Friday, and it's good because we have the day off. Huzzah! So this does, in this course, put us somewhat behind, as we are losing 3/5 of our lecture time for this week, and that will have to be made up probably in the final week, cutting into our review time. So we don't have that much left to go, folks. We've got this week, which is exception handling and mouse events. Then we have the ArrayList API, which is, as topics go, it's reasonably light, and they often don't even test it on the exam. Don't quote me on that for the semester, but that's often the case. And then the final week is just review. So because we're missing Friday this week, we'll have to push stuff down through the weeks so that we get everything in. Question?
That test 3 there, is there a test 3 and then the review, or test 3 and then the exam, or is...
For whatever reason, the curriculum documents consider the exam to be test 3. So test 3 and the exam are identical. So when we say test 3 review questions, we mean exam review questions. Good. Question?
I don't see that on the modules.
Oh, yeah, that's because I haven't published it.
Okay.
One moment, if you please.
He's keeping it secret.
Keep it secret. Keep
Good
it
luck
safe.
on the next test.
Just not with this review.
There we
Alright,
go.
no, go on.
No, the review is all mine. It's all mine. No. So, any questions about? Ooh, we had some questions about assignment 7, didn't we?
Yeah,
All right.
the UML diagram.
Apparently, various things are in various states of disrepair with respect to assignment 7. Oh, I need
Yeah, you need to go to modules.
modules. I hate that. Why isn't it linked?
I agree, it should be. I thought that was just you being lazy, but that's a thing.
So it technically is me being lazy, as I could fix that if I wanted to. But I do the normal thing that everybody does, which is I take the materials I receive and do not modify them from the version that the course writer puts together.
Fair
So,
enough.
Yeah. Anyway, enough said about that. Assignment 7.
Zoom tight.
So, since there seems to be a list of problems with assignment 7, let's write them down. Okay? So, problem number 1, and this is one I'm already aware of, is,
Nail gun.
yes, in nail gun, we have a,
Here's some calories for you.
yeah, we have nail gun has calories
Maybe.
in constructor.
Probably should be rental cost double.
I don't know, eat it like a nail, isn't it special?
So we've got price, rental cost is required, rental cost is here. So we've also got price though, but price is up here. So yeah, calories should be rental price. Calories
It's actually rental cost.
should be rental cost. Yes, I will make that an official thing. That's official now.
Rentable hardware.
Rentable hardware, where are we? Rentable hardware, yes, what's
Two
the?
methods, rent and return. So that says that they're returning booleans. Those are setter methods. They're not returning values. Rent sets that boolean to false or to true, and return sets that boolean to false. Is rented is the getter method that gets the status of that boolean variable.
Yeah, it is occasionally useful to return a Boolean like success or failure, if an
The method
operation.
works, whatever.
Yeah, if the method works, so, in that case,
Even in the top, in the rentable interface, it didn't have any type.
Yeah.
Yeah.
Yes, it doesn't agree.
Consider it void then.
okay.
They're both void.
And I also found it didn't like return.
Oh, it's a keyword, yeah.
I
okay.
changed those both the return rent item and return item.
Yes,
That's just for readability.
I guess that return to.
Yeah, and return is a keyword, so you can't actually use it.
okay, so a couple of problems. Number one, in, rentable hardware, both rent and return should return void same return. If you've already corrected the name so that it compiles, feel free to keep the corrected name. If you haven't yet, my recommendation is to find some synonym. Let's see here.
Look back on shelf.
Give back.
Like a
Give back,
product-
sure. Send back, get back, ride back,
Get back. That
take
sounds
back.
like real street.
payback. Payback!
That was like the greatest Mel Gibson movie ever.
Remit, maybe. Restore, replace, reinstate,
Probably could
reinstall.
just call it return product and. be
I
done
think
with
take back or return, or no, return is, yeah, like give back is probably,
it. Baby gave back.
yeah.
Return product.
Or return product, yeah. Whatever it is, return is a reserved keyword and you can't use it. So that should tell you whether or not an implementation was made of this assignment before the assignment was published.
And one final problem.
One final problem.
Rentable hardware and the UML diagram does not have a two-string method. If you go to page 2 of 3, it says, and I quote, "Notice that the box of nails and nail gun two-string methods are incorporating the Tim's product and rentable hardware two-string methods."
Sorry, which paragraph is that?
It's on page 2 of 3, right under the get amount due method.
Get amount to,
Scroll down a little bit, right there, last
oh, here we
paragraph.
are.
So I guess rentable hardware technically has a two-string method because it's inheriting it from Tim's product.
Yes.
And then wouldn't it just say like Tim's product and not Tim's product and rentable hardware?
Yeah, because it's getting the rentable hardware from the class.
You have to get it if rentable hardware
Oh.
doesn't have a two-string method, then you can get it from nail gun using the
Rentable-
get superclass method.
I'm reading between the lines here. This is roughly speaking what the what you get generated as a two-string for a class. using, like if you do alt insert and
Yeah.
generate the toString method.
Yeah.
So I'm going to say that yes, the rentable hardware toString should exist.
And it makes it much easier to get the rentable hardware class name.
Yep. So, point 4,
If we done it other way, should it be okay? Or should we? keep it?
yeah, if you've already completed the assignment, then don't worry about these changes, so long as everything works.
It works.
But,
It looks good.
rentable hardware should have,
Because, rentable stuff has characteristics that Tim's products don't. It should have its own use for.
toString. Well, I mean, toString is something that really should be overridden at every level of the hierarchy,
I don't disagree.
Question of that.
In regards to the rent and return, wouldn't it be beneficial for it to return true or false? Because if you use rent for something that's already rented, it should tell you that it's already rented.
Yeah, I think that this is also a fine way to implement this.
What's the is rented for then? Well, you should just use that method to check the variable first.
So, yeah, but that's, okay. So this kind of gets into a somewhat finer point of object-oriented design, actually. So, when you design a method or a function well, you do not require the user, the end user of that method, to make any additional checks in order to use the method, right?
Okay.
Any checks that the method needs to perform, it should perform itself, right? Rather than relying on that knowledge being known to whoever is using that method, right? So, if
Just call it is rented.
if the rent method doesn't, fails if the item is already rented, you basically have two ways of relaying that information to the end user, right? You've got a sort of scripty language PHP style way of doing it, which is return true or false from the method, right? Return true or false from the function, and you can do a post check to see whether the operation succeeded or failed.
Okay.
The other way, which is what we're going to be exploring today in Java, is you can have the thing throw a custom exception when you're trying to rent something that can't be rented. I am kind of inclined to think that throwing a lot of exceptions around needlessly is dangerous and stupid because an exception will break the program if not handled. But so long as the exception is handled properly and correctly and you're careful about it when you use it, everything should work out fine.
So then the rent method should just call the is rented, and then,
Yes, or it has access privileges to
sure, but,
it directly. It
but
can
isn't
do
the
it that
point
way.
of object orienting to reduce all the extra code that you're writing? So why recreate the is rented method within rented?
Because like if all you're doing is reading the state of a Boolean variable, like you're actually making the program slower just from the function overhead,
Okay,
you know? At some point, like, we do have to have a trade-off between, like, proper design and speed.
proper design would be a procedural oriented programming. Or
Well-
maybe functional oriented programming.
Well, actually, I do have good respect for object-oriented when it's done properly. It just needs to be done properly, and things like
That's hard to
Python
do.
don't do it properly. So, but anyway, so is that all of our questions about assignment 4?
Assignment 7, yes.
Assignment 7, pardon me.
Yeah, one last one. I couldn't, there's a section where it says you need to add one rentable, one unrentable. Are
Yes.
those ones that were included as the nail gun and the nails, or do we need to add our own?
That will be in addition.
So-
Okay.
Yeah, so like door hinge for not rentable and like leaf blower for rentable.
Yeah.
For example, yeah.
It says at the end of the first paragraph there, you must add one rentable product and one that is not rentable.
Yes, so
That exists.
when it
beyond
says
the
add,
building.
it means add in addition to what's already here.
Isn't it?
This kind of, once again, gets into, like, some of my, constant gripes about the way that object-oriented is represented in this class, which is, do you really need a new class for that? You know? Like, I would say that the characteristics of the nail gun class do not sufficiently differentiate it. That container could fit a lot of different shapes. Your leaf blower, for instance, what would you add to this?
Nothing. I don't
So
think-
do
I
you
don't
need
think
a
I did.
different class for that?
No, you just need a.
No, right? You need what you want is a name string here
Yeah.
rather than like a
Just
nail
generic
gun,
rentable object.
right? So, but if you were to like minimally, to make it worth making another class, you should have a few more different
Well,
instance variables.
sure, the way
right?
they have it set up, they'd make a class for every single item in their store, and that can't be right.
Certainly not. What actually happens in these things is that these things are kept in great big giant SQL databases most of the time. But yeah, so like when you're making your new class, to take leaf blower for an example, some things, it's a class representing leaf blowers, right? So what are some characteristics of a leaf blower? Is it gasoline or battery powered?
Yeah. the
Right.
speed-
If it's battery powered, what voltage is the battery that it takes, right? What's its maximum airflow capacity or whatever it is? Like characteristics of a leaf blower. Here, it's like features as a string. It's like, what that is a failure to think about the problem,
I don't
Yeah.
disagree.
right?
Well, obviously, they got calories in nail gun.
So you wanna know like the actual reason that get out of here, stupid news.
Maybe they wanna see like how many calories it burns when you use it.
How many calories you know?
Okay, so if you want to know the actual reason, it's that this is a hasty reskin
Yeah.
of last semester's or last year's assignment of roughly similar structure, where it was Tim Hortons instead of Tim's hardware store.
I know, all I can think of doing this assignment is coffees and doubles and donuts
Yeah.
and stuff.
Yeah, it was like, instead of like,
I gained 4 pounds.
instead of, non-rentable and rentable hardware, you had, bakery and beverage items, beverages implemented drinkable, and that's, stuff like that.
Okay.
I'm not going to say that this is a hasty reskinning to the point where even the UML diagram didn't really change in its structure, but, draw your own conclusions.
We'll just heavily employ it.
Yes.
Okay, that's fine.
That's what I do. You probably are used to me by now. I don't want to say something, but I will heavily imply it. So, shall we talk about the actual learning material for today?
I think we gotta get you a remote button for your camera to
Uh,
turn it on. Turn it back on.
No, this is part of the delight, of the streams is like, Did he just say the quiet part out loud?
I guess the other way, you're gonna look at it and see like 10 minutes, okay, and then 20 minutes past, like, no worries.
Oh, well, it's absolutely like well established in the lore at this point that I do not do any editing of my videos whatsoever. Even when people ask me to, I'm like, cause I like left it running after class and they were like talking about how their girlfriend broke up with them, and I'm like, oh, but that's worked for me.
Sad. You don't have a bash script that automatically does it?
No, no, that's unfortunately, if that was scriptable, man, no, you
I
need
don't
like
know, one of
AI
the-
for that.
One of the creators I watch on YouTube has
I got a new
AI
pointer.
editor.
There we go. I used to be known for these. Unfortunately I couldn't. The new ones don't light up,
They let teachers bring
so
weapons
not the
to
cheap
class?
ones. So yeah.
Bring my AK tomorrow.
So
Yeah,
we are
very
talking
nice.
about. I kind of like this one. It's a bit more solid than the ones with the light in the middle. So you know, it makes a better swagger stick. You know. So we're talking about exceptions. Does anybody care to define exceptions for me? Anybody have any idea what an exception is?
This is the first time I've ever seen
Yes, sir.
Isn't it code that runs in, except for the case where specific conditions are met, say there's an error or an exception to the rule?
So I think what you're describing is a try-catch. Yeah. So we have to differentiate our understanding. Try-catches are the things which handle exceptions, but they are not identical with the exception itself. Right? Anybody want to take another stab at it? Yes, sir?
It catches a specific error, and then it does a different thing with it.
Again, that's a description of a try-catch rather than a description of the exception itself. Yes?
Your exception is just an error. Any error in your program will throw an exception. You've got wrong variable types. You've got a pointer or overflow errors. A pointer. Exception is just your general class of error, and then you've got more specific ones.
Yes. So, in general, yes. So the exception is specifically a runtime error. So it is perhaps,
It's not a compiler error.
no, it's not a compiler error. The compiler does not need to produce exceptions. There's no reason for the compiler to handle one. Although, you know, reasonably speaking, if the compiler is written in Java, which I imagine it probably is, then inside of its internal structure it will be generating and handling exceptions. Internally contained, you'd never hear about it. But what you see as the end result is not an exception. It's a syntax error.
Yes.
Syntax errors are different from exceptions. Exceptions are specifically runtime errors. So, let us review the different types of runtime errors which we can have typically in a program.
Data type error?
Data type errors. So, this is when we're trying to assign a value of an incompatible data type.
Maybe the input user enters wrong data.
Oh, okay, yeah, that's a different one. So, in general, let's say that you have a Boolean literal and you're trying to assign it to a double value, right? That does produce an error, but it does not produce an exception. That is caught by the type checker, right? The type checker is part of the parsing and generation portion of the compiler. So, because it's a type checker error, it is not an exception.
Because it's not a runtime error.
It's not a runtime error. So, in general, you can't wrap syntax errors in try-catches to try to fix them. That would be hilarious if you could, but no, not the way that Java works. So, although that might be possible in Python now that I think of it. Anyway, so, yes. One of the first errors that we ran into in this class was way back at the beginning when we were taking user inputs using scanners. If you had a slot for a double, your scanner produced a string, and it was not compatible, you know, if you used next double, but entered a string, you ended up with a type error. right? A runtime type exception. Because Java runs inside of the Java virtual machine, it does a certain amount of this type of checking on the fly at runtime as well. But because it's part of, basically one way, okay. If you remember way back at the beginning of like one of the first things we talked about in this class, we talked about the difference between Javac, the Java compiler, and Java, the JVM. The compiler does the compiling, the virtual machine does the running. The compiler produces syntax errors, the virtual machine produces runtime errors. Now, in environments like IntelliJ, you run one and then immediately the other, and it does that continuously without requiring your input. So, it looks as if it's one big process, but it's actually divided into two processes, right? So, question?
Does like the program catches exceptions on its own, or do we have to write a code to catch exceptions?
So, this is a good question. Does the program catch exceptions on its own, or do we have to do something about them? We have to do something about them. If an exception is not handled, it ends the program.
That's a 130 error, right? And IntelliJ?
Oh, maybe. I'm not sure.
I think so.
It shouldn't end it in IntelliJ itself.
Well, when you're running the program and it ends
Yeah.
Yes, I think so.
unexpectedly.
So, to explain what exceptions are actually doing, you kind of have to understand what the system call stack is, right? Have you guys, I probably mentioned it at one point, but you guys know what the system call stack is? You want me to go through that?
Vaguely.
Yeah.
Okay, so, memory management, the only important topic in computing. Memory management. So, the system call stack then. The system call stack keeps track of which functions have been called, right? So, do you know what a stack is? Like as a data structure?
Like the last in, first out.
Yeah. So it's, or, yeah, last in, first out, yes. LIFO buffer. So basically, think of it like this, right? In your kitchen, you have a stack of plates or a stack of bowls, something like that, in your cupboard. Every one of you, probably. When you grab a plate in order to microwave yourself a frozen pizza treat,
Burrito.
which plate do you take?
From the top.
Yeah, you always take the plate from the top of your stack of plates. When you have eaten your pizza snack and you clean your plate and you put it back in the cupboard, where do you put it in the stack? You put it back on the top of the stack. So, despite the fact that you might have, 10 or 12 plates in your cupboard, you probably only use the top 3 or 2 or something like that, right? So, that is what a stack is, right? A stack is a data structure where we have a series of pieces of data. When we want to open up a new piece of data, we place that onto the stack. When we are finished with that piece of data, we pop it from the stack. So these are these are key terms that you'll hear a lot when you take data structures and algorithms, but putting something onto the stack is called pushing. Taking something off of the stack is called popping. the thing that makes a stack is that it's structured. You always know where you're popping from, right? You're always popping from
The top
the top.
And is it the data that we are pushing and popping?
So
instructions.
in a general stack, yes. Like you could make one of these with integers if you want to, right? You know, an integer stack has applications, for example, in graph algorithms, like finding minimum spanning trees and shortest path algorithms and that sort of thing. But we don't have to worry about that too much. If you want to know more about that kind of stuff, take Steve Adams's Math of Gaming class, which I highly recommend. I recommend it to people as like Algorithms Part 2, which is, it's a really good course. But anyway, so in the context of the operating system, the system call stack is composed of what they call stack frames. A stack frame is a region of memory used by a function. It also contains, it's like where the return value gets put before it's actually returned. A few other like technical things. But the purpose of these stack frames, this is the actual region of memory in which your local variables are stored. All right?
So that's a chunk of memory as opposed
Yes.
to a discrete individual piece.
Yeah, we're not talking about integers or floats or doubles or whatever. What we are you can kind of think of them as being big arrays, right? Because fundamentally what memory itself is it's a big array, right? But yeah, each one of these is a region of memory that can contain things like your x variable, your y variable, etc. Right? From some program that you're writing. So the question is, what happens when a function is called? Let's say that this is the stack frame for a running instance of foo. The foo function calls another function bar. Right? So it's something like, you know, foo int x equals 5, int y equals 10, bar 5, 10, something like that, right? What happens is precisely this. A new stack frame is allocated for the function call that we are making. We add or push a new frame for bar, right? This means that foo is no longer executing. Foo is no longer the one being executed, right? So one of the properties of the system call stack is that the function currently executing is always the one at the top of the stack. Always. So, while we are executing bar, nothing inside of foo is executing. We must have the computed result of bar in order to continue executing foo. Perhaps this is like return bar. We need to have the result of bar to return it, and then continue executing foo. Yes?
Can this be called like a memory stack, or would it be different?
So there are three terms for it. You call it the system call stack, you call it the call stack, or you call it reverently the stack. This is the stack. Yes. Other algorithms will have stacks, but this is the stack. All right?
One that holds them all.
exactly, one stack to rule them all. So bar is executing, right? Goes through, does its execution. It finds its computed result, maybe 5, passes that back to the previous call stack, or into the previous call stack, and then it gets popped.
You have to make that sound.
So, when bar finishes executing, its stack frame is deallocated. This is why scoping exists. Scoping of local variables. This is the actual physical reason. It's because the region of memory which you were storing local variables in while executing that function has ceased to exist. That's why local variables are removed and deleted once a function stops executing. The stack frame is where they're stored. The stack frame is deallocated, so it can be used by something else. The variables and like all of its contents, like so much dust in the wind. Yes.
Since in Java, if statements also have a block scoping, right?
Yes.
So is it also like a frame for the statement?
So, no, that has to do with the way that Java, like Java does more memory management up here than some other languages, like C. Like in C, you've got basically you're programming on like bare wire memory, working in memory addresses directly. Java has a lot of structure that like will be working this frame, but the thing you have to understand about the stack, there's a reason it's called the system call stack. It's not the Java call stack. This is an operating system thing.
So it's same for every language you use, or it works the same?
Precisely. This thing is stored, this thing saves routines through the entire operating system. So, you know, this region might be your Java program. If you actually take a look at like your stack traces when you get an error in Java, it's like you're usually inside like 30 to 80 different functions at any given time inside of a Java program, right? Subsequent to that, you have your shell, right? After that, you have your operating system. After that, you have your kernel,
Every single one.
right? So the further you go down the stack, the closer you get to the kernel, the closer you get to bare wire, right? So, you know, you're like at any given time, you're really only interacting with like the top little bits of the stack in user mode. You had a question? Not really? Okay. So, why am I telling you all of this? What does this have to do with exceptions? Bigger stick. Exceptions are a stack smash. They're a stack smashing event. So, you can think of it this way. Has anybody like played or seen that game, like that phone game where like you have the ball, right, and you have the little disc, and you have like a region here that the ball can go through, and it can like smash through several layers. You know, have you guys seen this game?
Smash the bricks.
Something like that, yeah.
Yeah.
So this is the exception. All right, these are your stack frames. The thing that stops this ball.
Can you repeat again what exactly is the game?
Yeah. So basically, this is not a paid promotion. Why is my camera so fuzzy? It's like, give me a second here. Yeah, it's terrible.
Focusing on your stick.
Maybe
Oh, I mean, it fell earlier.
it fell.
Yeah.
Like while you were here.
Ty was trying to put it in his pocket. He's like, oh.
Okay. Seems like I just needed to,
Add that to the edit list.
Yeah.
oh man.
Oh, I never read it.
The edit list that just sits there and never changes.
Those things just.
Yeah, no, it's, oh man. Give me a second, guys. Okay. A new stand just went on my Amazon wish list. Because that's just not acceptable. It's just not acceptable. You've got one job stand, and it's to hold that thing up. Your slacking stand. And you know what? Around here, as soon as you start slacking, you're out. So, yep, I think I'm gonna fire it, and I don't mind talking about firing it in front of it because, my goodness, it had one job. Anyway, what was I talking about? Oh yeah, stack, smash, stacky smash. I'm gonna just in my brain call this game Stacky Smash now. So anyway, it's like you've got like a series of things that look like hard drives, you know, and you have these like colored wedges, right? And you can control the rotation of these disks, and you have a ball, and the object is to get the ball to hit these in the sort of weak point so that it smashes through, and your object is to like navigate a series of these while it's like going up Tetris style, and if it reaches the top you lose or something like that, right? You'll, you know, if you Google it, I'm sure you'll find it, whatever. But anyway, so what an exception does is it smashes the stack until it hits something handling the exception, right? So at the bottom of your series of Java functions, you have the JVM itself, right? If an exception reaches all the way down to the JVM itself, it stops itself. It doesn't, like, the JVM does not, like, crash gracelessly, if that makes sense. Like, it does crash, like, it doesn't crash, right? What it's doing is it's stopping its own execution and outputting whatever the error messages that accumulated are on this exception that's smashing down through the stack, right? So let's say, for example, you had some kind of typical error like an index out of bounds exception, right? Index out of bounds exceptions are a very typical error. I'm sure you've all seen them. It goes through and says, am I in a try-catch? No. Smash. 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 Am I in a try-catch? As a matter of fact, yes. And then it outputs all of its data to the console, and that's how you see the exception. Yes.
Is try-catch the only way for exception handling?
Yes. So the only thing which catches an exception is a try-catch. So try-catch, you can imagine as like, and this is where the metaphor starts to break down, you can imagine it as like a great big baseball mitt waiting for any exception that's thrown.
And is there any difference if you're using try-catch or if you're handling the errors by writing a wrong code? Or
What do you mean by handling the errors by writing your own code?
I mean, like checking the errors in the program on your own with the if statements and?
So that's a good point, actually. So up to this point in this program, pretty much all of your error checking has been proactive error checking, right? Try catches are reactive error checking. They check for errors, like you're setting something up for after the error occurs, but the error has to actually occur for the exception handling code to execute. The purpose of all of these if statements and guards is to prevent these errors from happening in the first place, right? So that's the main difference, right?
So we can do the exactly same things with both ways?
Well, not really. They're like, there's no if statement you can write that will prevent a user from, well, I guess I shouldn't say that. I was about to say, like, you can't prevent a user from entering a regular string when a double is expected. But actually what you can do is you can read it in as a string and then try to parse it as a double and before you use it. Yeah, it's another one of these things where you can do
Which
something.
one is better?
It's situational.
Oh.
Java happens to have a very good exception handling interface that can save you effort. So the better solution is the one that's easier and more reliable in most cases. And learning how to use exceptions in Java is easier than doing all of this proactive code that honestly you would have to debug, right? So, does this make sense? Does anybody have any questions about, like, conceptually what an exception is? So, exceptions in Java are objects. Because it's object-oriented, and pretty much everything is an object. So, exceptions are thrown by a method that gave rise to the error. The calling method can throw the exception, expecting something to catch it. That's why we are using the terminology try catch. One part of the program throws the exception into the air. Another part of the program is trying to catch that exception, right? This is the terminology for this varies by programming language, but in general, try catch is pretty common. You'll see try except sometimes, like I believe Python has try except. In Python the terminology is you raise an exception, which is handled by an accept block. In Java you throw an exception, it's handled by a catch block. Does that make sense? So, okay, we're just gonna do some code examples now. That's easiest. Boot up IntelliJ.
there example code that we should be getting?
I'm gonna work it up from nothing.
Oh, yeah.
See, when you do an example from like literally no starter code whatsoever, you tend to end up with a minimal example, you know, which I think is better because, you know, like if I just throw 50 lines of code at you, it's like, well, I need to probably understand these lines of code before I understand the thing that we're talking about, you know. Reading code is long and takes effort and is difficult, and even if you are an exceptionally gifted programmer, nobody likes reading code, you know?
Are there little jokes in the comments?
I mean,
Can't have enough Monty Python references.
No, my jokes are on the code.
so, there we go. Let's make a new Java class. Call this exception handling. There we go. Y'all can see that, I hope. So, public class exception handling. Let's make ourselves a main method. There we go. Let's let's make a function. Public void Baltimore Bridge because this will be broken.
People die.
I think that might be too soon.
Is it too soon? Okay.
I think
Yeah.
so.
Okay.
It's fine.
Whatever. I'm leaving it in. So, some things that can cause exceptions. Accessing an index of an array that doesn't exist. Another common one is zero division. Computers cannot handle the idea that you might want to divide something by zero. If you did that in a math class, what would the answer be?
Undefined. Undefined.
Undefined? Sure.
Cannot compute.
An F.
Cannot compute.
Not a
The
number.
limit does not exist.
Infinity.
Often it's infinity, right?
Yes.
Yeah, like there are a lot of like strange answers, and one of them includes this is infinite, right? So if like 5 divide by 0 is infinity, right? Or the limit as the denominator approaches 0 goes to infinity, something like that. Do we have infinite bits to represent numbers with?
No.
No, we are constrained to reality. So, we do not, with the exception of certain languages which do actually have like an infinity keyword, right? Like some have an infinity literal, right? Well, languages like MATLAB, you guys probably haven't run into MATLAB. MATLAB stands for Matrix Laboratory, and it's rather Fortran-like. It's kind of got Fortran-like, but it's also very expensive software.
Forgetting to mention it's also terrible software.
Yeah, it's not. I mean, scientists like it, but that's probably because they don't.
Engineers don't, sir.
No.
They all hate linear algebra, and MATLAB's half the reason why.
Yeah. There you go. Anyway, so basically we've got no way of representing infinity, so that is a problem, a big problem. That's actually a problem at the level of the operating system. The CPU raises an error flag if somebody attempts this. This is like deep in the computer system. It doesn't like that. So we can provoke our computer to anger simply by trying to calculate int x is equal to 10 divided by 0. Oh, it needs to be static. It needed to be static, but then a ship hit it. So, there we go. We run this. That's what you come to my class for. Coding and tasteless humor. So,
That's a good one. That's acceptable.
exception in thread. Where do you get the 130 number that you guys were talking about?
That's, I think, when you stop your program when it's running.
Oh, okay. Okay, because this is finished with exit
Yes.
code 1.
Yes, that's
so,
your error code.
Yeah. So, at exception handling dot Baltimore Bridge exception handling line 4. So it tells you what line the exception occurred on. At exception handling dot main line 8. So it smashes through this execution to find this one, smashes through main, finds nothing more to smash through, so the JVM barfs out the error. Right? So,
So if we have the exception in the name, where would it be cancelled?
let me show you.
So you want to try Baltimore Bridge and then catch the exception that
You
it
do. So if I had int y is equal to 20 divided by 0, right here, here's the difference. We are only smashing through main, right? We are no longer going through this one to get this one. This one has produced its own error all on its own. So, let us see how one goes about handling an error. Try not to hit it with a giant ship. Catch. There we go. Now, some languages will let you get away with less than this, but in Java, catch kind of has an argument, like it looks like it's a function call. Exception, E.
Can you call it E anything?
Yeah, you could, that's just
Just by
a name.
convention that it's E?
Yeah, it's typical to use E, but whatever.
Is error a reserved word?
Maybe? No, but it seems to be used by stuff, so.
So I won't call it exception error anymore.
So, this is the way that a try-catch works. When an error is encountered, here, if it occurs inside of a try block, this block immediately stops executing. Immediately stops executing. You immediately jump to the catch. So, for example, whoops,
There it is.
an error occurred. And here, if we type
No error.
no error occurred. You can see the output we get is, whoops, an error occurred. Notice, we are no longer getting the stack trace, right? The program does not terminate when it encounters that error anymore. We do not get the stack trace output because the exception did not find its way all the way to the JVM, and instead we execute the contents of the catch block. Yes?
So does this mean it didn't break the Baltimore Bridge stack frame?
It did break this stack frame,
Okay.
but it did not break main because main caught it, right? So, in effect, it's almost like this method, when it encounters an exception, immediately returns the exception. Like it's returning as well. Like the method itself stops. This function stops as soon as the error is encountered. Does that make sense? Now you don't have to do it at this level. You can also do it at this level, right?
Yes, thanks.
So does this mean like we won't get any runtime error?
Yeah, and then that's what I
Precisely.
go with.
So in this case,
That happens
if we
by
catch the error
the valid-
inside of the Baltimore Bridge function,
I don't know.
the error is raised in here.
Even at home.
This try catch catches it. We immediately execute this one. Print, it's pizza time. Then this function executes successfully at this level. No exception has occurred because it was caught up there, right? So we then execute no error occurred. Does that make sense? Good. Oh, yeah, of course.
You got allergies?
Yes, I do.
So
Might be.
I would say that the try catch is a bit of a distant cousin of the if statement. Right. The condition here is if an exception occurs while I'm executing this block, then execute that block immediately. Make sense? Good. So yeah, that's like roughly speaking how it works. A couple of other points. You can create exceptions without having to use like stuff like that. Using throw. Throw exception. This is Java, so you have to throw a new exception because you are creating an exception object. You have to call the exception constructor, and I believe if you
Can you predefine that, like exception P equals new exception someplace else?
yes, you can even, because this is object-oriented programming, define your own exception types.
I don't like the look, cut of the of exception.
So you can see here, we are catching an exception because it's saying it's pizza time. If I were to remove, let's say I just put this down here outside of any try block, unhandled exception, yes I know. Okay, so it doesn't like me doing that. Okay. Fine. I don't care. Oh, man. The type checker is fighting me on this one. So, we must satisfy the type checker. The type checker needs to know what sorts of exceptions a method might throw. So, if it's possible that a method simply throws an exception instead of just plain executing, we need to use the throws keyword and specify what type of exception it may be throwing. It might throw it, it might not. In this case, it does. Whoops, an error occurred. So, further, let's talk a little bit about the properties of the exception object itself. All of the stack traces and all of the error messages that you receive are contained within the exception object. This is how it passes down exceptions. So, e dot print stack trace allows you to print the stack trace without terminating the program. Right? Here's our stack trace. You can see it's occurred after, whoops, an error occurred. Probably the fact it's in red means that it's being output to standard error rather than standard output. E.get stack trace. That should be a string array. Errors is equal to stack trace. Did I get that right? Let's see here. Stack trace element. Oh man. Java. For stack trace element q in errors. What? Get out of here. Q dot get like toString and then S out that. And there you can see it's in black now. That means it's being output to standard or system.out.print, right? Rather than system.error. So, do you guys know about standard input, standard output, and standard error? Okay. So, very briefly, yeah, Mr. Networking guy at the back, I'm sure, because you have to do shell scripting.
Yeah.
Yeah, you have to know how to redirect these streams. Would you care to give us an explanation of what standard input, output, and error are?
Not particularly, but I can try.
Well, come on.
Okay,
It's
so
yeah.
standard input is the input into the system. So it's usually like keyboard, mouse, etc. They'll have key codes that are input into the system. Other ways of inputting input, yes. So there's the output, which is what the system spits back at you. And then the system error is all of the error messages that are output by the system.
Mm-hmm. So, system or standard error and standard output are functionally equivalent. When you're in a command line interface, the command line interface shows you both. But it's at some point early in the development of Unix or something like that, it was determined to be useful to have a separate output buffer just for error messages. And so that's what standard error is. You can access standard error by just replacing out with ERR for error. But anyway, so lots of nifty information contained in the exception object, including all of that stack trace information, even if you handled the exception. Question?
And do we only get a system error if it smashed the system stuff?
Nope, you can print to it anytime you like. See how it's read? Red is just IntelliJ's way of saying this came from standard error. Many command line interfaces like Bash do not distinguish between standard error and standard output. They don't like color standard error red or anything like that. You just get both. Make sense? So, an exception causes the current method to halt immediately and throw the exception to the method that calls it. Yes? Might throw an exception. If the main method throws an exception and the program terminates and the JRE or Java runtime environment prints a stack trace to a special error stream system.error. I don't know if you'd call it special, but it's just the error stream, but that's okay. So when you have a try except or a try catch, right? No matter what happens with the try catch, execution continues normally after it. Whether an error occurs here, like if an error occurs, it executes this. If no error occurs, it finishes executing that. Either way, at this point, you just keep going. Every exception object contains the stack trace to show where the execution happened, or the exception happened, and a string message that provides more information about what went wrong. So, up to this point, we have been talking about exception E. This is one class among many. So this is how Java internally structures exceptions, right? You've got throwable inheriting from object. You've got exception inheriting from throwable, and then you have a number of exceptions. This is not a complete list, inheriting from either runtime exception or from an exception directly. So, for example, arithmetic exception, right? Arithmetic exception is the type of exception you get, I believe, when you div 0, right? Arithmetic exception inherits runtime exception, which inherits exception. You can check for each of these different exception types individually by including multiple catch blocks. Multiple catch blocks which handle each of the individual exceptions individually. Now, hopefully, this is where the beauty, the awe and majesty of inheritance and the object-oriented paradigm comes through. Because what does it mean when we just inherit from exception? That is a variable of the supertype,
Yeah.
which means that this can be any subtype,
Yes.
right?
That's the general class.
So, you can have interrupted input mismatch, arithmetic exceptions all down the line. And if you want the final one to catch any of these that, like any exception that you didn't get, you add one more, just do exception, E, and that's like your else case.
It's like a switch almost.
Yes, except what you're switching on, it's like a switch case that operates over overloading, you know? Because what this is we are overloading catch with all of these different local definitions for exception, and,
There's-
but it's, at the same time, there's like a linearity to it, right?
Else statement.
Yeah, the else statement would be catch exception, catch the superclass. You have had a question for a bit.
Yeah, just wanted to ask, since we are saying like exception, so instead of like Java or JVM, returning an error or giving an error, it returns an exception, right? So, it just means like it didn't break the JVM stack, it just returns an exception, so that.
So run me through your scenario
Like
again.
in Python or in another language, it gives an error, right? But in the Java, it gives an exception instead of an error.
Well, technically Python also does exceptions. What you see most of the time in Python is an exception and not an outright error. What you'd have to go to is a language that doesn't do errors in a proper sense. For example, my personal favorite programming language, C. C does not do exception handling. But C also, like, I sometimes tell students that like Unix is the integrated development environment for C. So like the way that the C programming language was designed in concert with the Unix operating system. So many of the functions of the Unix operating system parallel this type of thing, exception handling, except it's built in at the operating system level. And C's attitude is, why would I need that? The operating system is doing it, right? So what operating systems have are signals, not exceptions. So, okay. I'm going to sully myself by bringing out a Windows example. But, so, you know, in Windows, when you have a program that's not responding and you need to kill it, right? You guys know the procedure for that, I assume?
Task manager?
Task Manager, what's the shortcut?
Alt-delete.
Used to be Control-Alt-Delete.
What's the better one? I can't remember.
Yeah, it's now Control-Shift-Escape. Used to be Control-Alt-Delete, yeah. So, Task Manager, Control-Shift-Escape, there we go. More details, please. There we go. It's a list of all of your processes that are running, right? What happens when you click End Task is that the operating system generates a kill signal for that application's process ID, right? So each of these are processes, right? Each of these have a process ID. Clicking End Task says send kill signal to process with process ID that one. right? So, you can kind of think of that at the operating system level as an unhandled exception. As it turns out, C programs can handle signals. So it is possible to write a C program that is unkillable. Because you just have it handle, so the way that it works in C, you write a function to handle the signal, and then you associate that function with the signal, and then as long as that function reassociates itself with that signal, you can infinitely handle something like a kill signal, and it never actually kills the C program. Yes?
Can you kill it by killing its parent? Or is that only Linux?
C, I don't know that much about how Windows does things, you know, but if you're just running your own C, you know, so if you're just running it like a C executable, right, then the parent process in that case is the shell. So killing the shell will kill all of the processes running in the shell. Does Windows work like that? I don't know. It seems like you don't need the more I Linux, the more I'm like, how is it in Windows that you can just write to the root of the hard drive? Like any user can just write stuff to the root directory of the hard drive. Why? Any user can do that. There's no reason. No reason. Anyway, so what was I talking about? Oh yeah. So let's talk a little bit about this distinction here, right? Runtime exceptions versus non-runtime exceptions. What do you notice about these two exceptions as opposed to these ones? What are some differences you can pick out? Can you hypothesize why those two are not considered runtime exceptions?
It happens outside of the runtime?
Precisely so. These are these are exceptions originating inside of your Java program. These are exceptions originating outside of your Java program. Interrupted exception. Interrupted exception is what you get if somebody or something, the operating system, tries to kill the process. Right? One of the things that Java does is it tries to fail gracefully. Right? Rather than just fall flat on its face and die, it tries to land on a pillow. Right? So, rather than receiving sigterm, which is signal terminate, which is the signal that you send if you try to end a process, what it does is it takes that signal, it handles it, it's like, okay, I just received a kill signal from the operating system, you guys need to shut down. It immediately generates an interrupted exception, and the JVM's like, I'm going to do my graceful exit process all the way down, like, there's no way to predict this one coming in, right? So this will kill your Java program most of the time because, like, who plans for that, you know? Unless you're writing a programming example for a class, who plans for that, right? It's like writes infinite loop, writes handler for interrupted exception that keeps you inside the infinite loop. File not found exception is relatively self-explanatory, right? When you are trying to access a system resource, the operating system is responsible for telling you whether or not the file exists. If the file that you're trying to access does not exist, You get a file not found exception. Now, with this type of error, you can predict when you're going to run into one. It's when you're trying to access a file, right? So, you can predict that one, you can handle it. You can't predict this one, so you can't really handle it.
Can you wrap your whole program in a try block and look for an interrupted exception?
You could. Yep. I wanna, I kinda wanna do that from the command line, actually. You know what? That's kind of an interesting one. Why don't we try it?
Crashes the server.
I don't know if this is going to work. We'll see.
And then
Let's
when you
make
try
a
to
new
shut it down
class.
through the task manager, it should say, no way.
How broken
It's the bridge.
can we get? Let's find out. The bridge is extremely broken. Did you guys see the footage of that
Oh
bridge
my god,
breaking?
that was so bad.
Yeah, it's like
That
it
just shows you
collapsed
how-
almost instantly.
How
Yeah.
huge and how much inertia those giant container ships have.
Yeah, I heard that at the time of the impact, the ship was only traveling at 1 knot,
Yeah,
which is like very, very low speed.
well, they lost their power and they couldn't maneuver anymore, right? So they just floated into the bridge.
Yeah, well, it's very interesting because if you take a look at the footage, there's like a black plume of black smoke coming off the engine stack. Like once they get, because like they lose power and then they get power back, then they've got like a black plume of smoke coming off the engine.
Some pops off.
They tried to, basically the problem was, from the analysis I heard, they tried to stop the ship, but what they should have tried to do was steer the ship,
Yes.
right? As-
Through.
Right, because like, you are talking about just a stupid amount of inertia, right? Much easier to deflect it from its course than to get it stopped. Like they dropped the anchors and stuff to try to get it stopped,
That's not
but,
gonna do nothing.
well,
That's a million and a half pounds.
yeah, you've got like think of it like this, right? You've got an elephant and somebody dropped a fishing hook behind it to try to stop it, you know? But anyway,
I saw some interesting tweets from the old Andrew Tate
oh yeah?
about how it's a cyber attack on the ship. And yeah, saying that someone hacked the ship, gained control of the ship to crash it into the
Probably
bridge.
not. Occam's razor says that that's bullshit.
They've already analyzed it, they reported that that was not the case.
There was
Yeah.
no results, like nothing that
If-
would even imply that.
If I may say so, we live at a strange point in human history where like the kook sphere overlaps with the regular news to a great degree because of social media. So like
Real big
an accident can happen without there being a conspiracy behind it.
Yep.
You know, like, you know, think of like Costa Concordia, right? That's just somebody didn't do the correct emergency procedure for a ship, and the ship hit something it wasn't supposed to. You know?
Apparently the captain ordered them way too close to the shore because he's like, I wanna show off the ship.
Yeah, and having done that, like they
Those things break.
didn't estimate distance to shore correctly or something. But like they also, like it's another problem, like ships are very different from cars, right? Like,
They're more like trains.
Yeah.
You steer a car, you guide a ship.
correct, yeah. And it's like, it's something that like landlubbers such as us, who, we can't really appreciate how ships behave unless you like have been out and on a ship. Particularly if you've tried to subject a ship to your own will and tried to steer a ship, you know? Something else, like even a rowboat can give you trouble, you know? Anyway, I make jokes of course, but it was a horrible tragedy. The footage was quite something though. Like, I was surprised by how instantly that thing
Yeah.
collapsed.
Cause a human would like think that that bridge was immovable, and then it
Yeah.
just crumbles as soon as its ship touches it.
As
Just
like
crumbles.
as soon as that pylon was taken out, it looked like it collapsed like wet paper. It was incredible to watch.
As soon as one was gone, it all just.
Yeah. Anyway, what was I trying to do? I was trying to
Break
handle
it.
an interrupted exception.
Yes,
So this example is going to assume that the stop button up there sends an interrupted exception in some way, which seems reasonable. So let's see, main while true,
there we go.
S out. This is the song that never ends. There we go. Try catch, or try exception. Try interrupted. Exception. Try that. Mhm. Oh, wait, pardon me, that goes on the catch, doesn't it? There we go.
You need to add the exception to the
Yeah,
return.
that throws new exception there on the main.
Like that?
I think so.
Interrupted exception is never thrown by the corresponding try block. Oh,
Huh. So you can just sit there waiting for one?
in theory though, it's a subtype of exception, so we should be able to catch exception and catch it too, right?
Yeah, because the exception contains all the different.
What's that thread dot sleep?
Little J. That's just thread.
You have to add the exception.
Yeah, I'll shift enter.
Alright. Oh, this one. Although, I should put everything in here, shouldn't I? Because what if the exception occurs while I'm waiting, which is highly likely. Listen, I want this one run. Run. So- Why is it running the other one?
I don't know. I don't understand.
Maybe I'm just clicking the wrong one. Yep, that's it.
Yeah, I'll go. Yeah.
So, there we go, infinite program. Let's see what happens when we click stop. Ah,
That's your 130 exit.
yeah.
Yeah, that's good.
Is this a general, can I send it kill signal?
Try with
Can you do it with,
Alt Control F2.
yeah,
Control F2?
No, with the task manager.
yeah, try with task manager.
Oh, I think that probably won't work, but okay, we'll try it. Run this. Let's see here. IntelliJ.
Well, I think it's a sub. One of those.
Oh, yeah.
Untitled for Outlook, that one. Nope.
Nope. Okay. You can probably get it to work in terminal.
Well, we stopped it.
Yeah, we did. We stopped the madness. So,
I don't know.
Why not?
so it is absolutely 100% possible for you to write your own exceptions. Probably you don't need to most of the time. The set that it comes with is pretty good. But if you find yourself in the need of a not enough frogs exception or something, all you do is write an exception inheriting one of these two guys, and you pick up all of the important and useful properties of an exception, and that's, boom, you've got your own exception type. That's object-oriented for you. Does that make sense? Good. So, of these exceptions, some are checked and some are unchecked. As we were playing with exceptions, you noticed that at certain points, the compiler was complaining about, we're writing a catch block for an error that doesn't happen or something like that. We have checked and unchecked exceptions. And exceptions that extend runtime exception are unchecked exceptions. So, for example, arithmetic exception, there is actually no way for the type checker to know whether a zero division error is coming. It can't check it. In order to know that, the type checker would need to run the program. But the type checker doesn't run the program. It only does an analysis of type interactions, right? And because it doesn't actually run the program, that means that the type checker terminates, whereas the program itself might not terminate. This is why this is an important property for compilers, but you don't need to worry about it. Exceptions that extend exception directly are checked exceptions. Examples include interrupted exception and filed not found exception. If your method, if your code calls a method that might throw a checked exception, you must satisfy the catch or specify requirement, or you get a syntax error. That means that you must either catch it or specify in the method header that you want to throw it instead. So, if, for example, you are, in our previous, in this thing that we were using, thread.sleep might raise an interrupted exception, right? We are now under a syntactic requirement to either pass that exception through by saying this method also throws interrupted exception, or you catch it and you handle it. Make sense? This is how you indicate that a method throws a particular exception. You just say throws exception type in the method header, making Java yet more verbose. Java truly is one of the most verbose languages I've ever seen. So, we kind of already talked about throwing exceptions, but we will come back to that next time, which is to say 1 week hence. same bat time, same bat channel. Which is a reference to the old Batman television show, for any of you Zoomers out there. So, any questions?
When's assignment 8 due?
April 12th.
That's a good question.
April 12th, and we can't use any late days, right?
Correct.
So use them all up on this one.
Correct.
Me too. That's what I planned.
So, April 12th is
Last
the
day.
last day before exams. It's the Friday before exams start. You must get assignment 8 through before then.
Oh, it's a Friday.
So,
3 days.
Do we need a material from 12 for this assignment, for 8?
do you need a what? Sorry?
Do we need week 12 material as well for assignment 8, or?
I'm sorry. Do we need a week 12?
Do we need the stuff from week 12 to finish?
Oh,
Or just as,
no, just the stuff from this week.
okay.
But we haven't covered it all. So, yeah, no, in terms of assignment applicable material, this week's module is the last module. Not that the other stuff isn't useful. Okay. Yes?
It says assignment 7 is due on the 27th.
It's today, yeah.
Oh, that's April 20, never mind.
Yeah, that's,
Never mind. I was
Yeah,
looking at
that's
that,
April,
I'm like
yeah.
27. That's a, didn't realize we have that much extra time.
there we go.
Today, yeah.
No, you've got no extra time.
I kinda figured it was today,
Till
but.
Late
11:59.
Yep, late days. Have you been
Yes.
storing your late days?
Maybe.
It is time to end it.
You haven't got,
Yes.
you haven't got assignment 6 marked, so I don't know how many I have left.
Um,
Oh, I got 9 out of 10. I think I used 3 on that one, so I think I got 6.
I planned my assignment 6 and 7 to use up all the late days.
good. I'll throw that together if I have a moment today. I'm sorry about the marking getting behind. It's been terrible.
That's fine. Still not as bad as Professor Cortesian.
Oh, yeah.
Well, as otherwise a fine teacher, but
Mm.
So our teacher didn't, Python didn't mark our first assignment until after the second half.